In this video, I want to show you an example of a function that doesn't just deal with numbers. So for our example, our universe is going to be the power set of the set 1, 2, 3. Oops. So remember that the power set of a set is the set of all subsets of that set. So for our example, our universe, is going to be the set of all subsets of the set 1, 2, 3. So let me just write out all of the subsets of the set 1, 2, 3. We have the empty set, the set with 1 in it, the set with 2 in it, the set with 3 in it, the set with 1 and 2 in it, the set with 1 and 3 in it, the set with 2 and 3 in it, and the large set itself, the set containing 1, 2, and 3. So this is going to be our universal set. Our universe has 8 elements, each of these elements. This one, 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 and this one. The sets themselves, the set containing 1 is one of these elements. The set containing 1 and 2 is one of these elements. The set A, our domain, is going to be the empty set, the set containing 2, the set containing 3, and the set containing 2 and 3. This will be our domain. Our target is going to be the set containing 1, the set containing 1 and 2, the set containing 1 and 3, and the set containing 1, 2, and 3. And now our function, f, is from A to B, and the rule is f of s equals s union the set containing 1. Now you might say, what is s? So we could add this extra information, which is not really necessary if you understand that f of s is what you do to s to get over to b. But in any case, I think it'll add something a little more understanding, so I'll put it in. Where s is an element of A. Okay, so S can be either, so there's really only 4 things that S can be. S can either be the empty set, the set containing 2, the set containing 3, or the set containing 2 and 3. So this is our function. Now let me show you that this is in fact a function, and I'll show you that by graphing and making a table. I guess let me make a table first. So let's say S and f of s. Inputs and outputs. So over here is going to be elements of A, and over here is elements of B. So the elements of A are the empty set, set containing 2, set containing 3, and the set containing 2 and 3. All right, so what does S do to the empty set. Now, f of the empty set, using our rule, this is the empty set union set containing 1. Right, remember, f of s is equal to s union. S is like x when you have f of x. It's just a placeholder. S is an element of A. So we just look at elements of A for S. Okay. So f of the empty set, what is the empty set union with the set containing 1? It's just the set containing 1. So that's what we have here. Right, now let's look at the f of the set containing 2. This is the set containing 2 union the set containing 1. And this is the set 2, 1, which is the same, remember, because order doesn't matter in sets, as the set 1, 2. So this is the set 1, 2. All right, now the set containing, where does f send the set containing 3? S union the set containing 1. Oh, and what is S, right? S is the set containing 3. This is the set 1, 3. Okay, and now lastly, let's figure out what happens to f of 2, 3. This is 2, 3 union the set containing 1. This is just the set 1, 2, 3. Okay, so here's our table. Now let's graph these things. The x-axis is going to be the set A. The y-axis is going to be the set B. Empty set. Set containing 2. Set containing 3. Set containing 2, 3. All right, my outputs, or B here, we have the set containing 1, set containing 1, 2, set containing 1, 3, and the set containing 1, 2, 3. And now I'll draw the points that are represented in our table. Let's see, empty set and 1, empty set goes to 1. Set containing 2 goes to 1, 2. Set containing 3 goes to 1, 3. And the set containing 2, 3 goes to 1, 2, 3. It's a little lower, but anyway. So now you can tell that this graph passes the vertical line test, and so therefore our function is in fact a function.